Assalamu alaikum. My name is RAHMAN and today our topic is about insertion sort algorithm. In my group there are also 4 members. You can see their names and matric number. In my topic, just about introduction. Let's talk about introduction. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. The array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. It basically supports an array of elements in order to comparing each element with the prior element and moving each element accordingly. Insertion sort is not the best sorting algorithm in terms of performance, but it's more efficient than selection sort and bubble sort in particular scenarios. Insertion sort is also pretty intuitive sorting technique. It's a rather simple algorithm.
Assalamualaikum. I am NAMIRAH binti HASHIM and my matric number is B0318100027. I will be presenting the part 2, which is the picture diagram of insertion sort. Okay, let's take a look how insertion sort works with this visualization. So now we have an example of the size of array 8 and the elements that yet unsorted. We have to sort this element using insertion sort. So the highlighted green elements to the left are always sorted. We begin with the elements in position 0 in the sorted portion, and we will be moving the elements in position 1 in the blue to the left until it is sorted. So we take a look at the elements in position 1, 33 and 14. Since 33 is greater than 14, nothing happened. And then we take a look at the elements in position 2. 27 and 33 have to be compared because remember we need to move the blue elements to the left until it reaches the correct position. And then we swap because 33 is greater than 27. So we take a look at position 3, and then we have to compare 10 and 33. So 10 and 33 is swapped. And then we swap again 10 with 27. We swap again 10 with 14. Next, we take a look at the elements in position 4 and 33 being compared, nothing happened. And then we take a look at the next element, which in position 5, we have to move the blue color to the left until it is in the correct position. So 19 and 35 being compared, swap. 19 and 33 being compared, we swap. 19 and 27 being compared, we swap. Then now, we already see that the elements are already sorted but not complete yet. So we see the position 6, elements 42. 42 is greater than 35, nothing happened. And then we see the elements in position 7. Nothing happens in 44 is greater than 42. Now we see that all elements are already in sorted place. So now we are done sorting with the insertion sort.
Assalamualaikum, I'm SUMAYA JERIN from BITS. My matric number is B0319205111. I'm going to present the algorithm of our insertion sort. So here is my algorithm. In insertion sort algorithm, there is two loops. One is outer for loop and one is inner while loop. So outer for loop is to iterate through all elements that are not sorted, and inner while loop is for pushing element to the right side and ensure that the next element is on right position. So let's see the example here. Let's say we want to sorted this array 4 3 2 1 to 1 2 3 4. So we will compare these two elements first, 4 and 3. So we will increment 3 in for loop as temporary variable. So in while loop, 4 will copy the position of 3. So the 4 will move to the right position of 3, and after that here 3 will go to in the first position. So we have to sort between 4 and 2 now. So 4 will again copy the position of 2, and 2 will go to here by this portion. It will go to the first position. After that, as we already sorted 2 3, so this we left only 1. So we will increment 1 in our for loop, and the 4 through while loop will copy the position of 1, and it will push to the right side here in the position of 1. After that, the 1 will go to in the first position. So as this array is already sorted, so this is the final answer. So we sort 4 3 2 1 through insertion sort to 1 2 3 4. Basically, the for loop works as to iterate the elements, and the inner while loop works for pushing the elements to the right side in its correct position, and it ensures that the next element should on the right position. Thanks for giving me time.
Good afternoon to everyone, and I'm Ravindran Genesan from BITS S1G1. My metric number is B0320103662, and I'm here to explain about insertion sort algorithm for complexity. Okay, complexity is an algorithm function describing the efficiency of the algorithm in terms of the amount of data the algorithm must process. And time complexity is an algorithm signifies the total time required by the program. For the space is a function describing the amount of memory that an algorithm takes in terms of the amount of input to the algorithm. So now let's see the complexity in insertion sort algorithm. For the worst case time complexity, it's big O n square, and it was for compares and also the shifting. And for the best case time complexity is big O n, and for the average time is big theta O n square, and for the space is O1. Example of worst case algorithm is okay, here we can see that here's two loops for I to n minus 1, and the inner loop is while j greater than or equals to 0 and ij greater than v do. So for here, for the output, I insert that the amount of the arrays is 4 3 2 1. So here it will use while j equals to or greater than or equals to 0 and aj greater than v to compare all the numbers with other numbers to arrange the array on ascending order. So for I arrows I to n minus 1 is to shift the numbers from ascending order from smallest to biggest. So for next is here's an example array for the worst case complexity. So here we can see that the numbers are arranged in not in correct position. So first is 5 1 6 2 4 3. So for here 5 will compare with 1, and if it's 1 is a grade lesser than 5, so it will move to left side. So it will so after that for the second and for the third, fourth, fifth, and after all these steps are gone, and for the final answer is 1 2 3 4 5 6. That is, the array was sorted in ascending order. So these whole steps can tell that the time complexity is n square. And for the example of best case is, for an example I choose 1 2 3 4 5 6 as the array, and this array is already sorted, but still we need to check whether it's in correct position or not. So we can check, it can see that all are arranged in proper position. So the best case is ON. And that's all from my side. Thank you very much.
Assalamu alaikum. My name is ABHOTEM AIMAN. My matric number is B0319205008. And as for my part, I am going to suggest another algorithm. Our algorithm is insertion sort. So I suggest to use bubble sort. Bubble sort is better than insertion sort only when someone is looking for a top key elements from a large list of number. In bubble sort, after key iterations, you will get the top key elements. Array is nearly sorted. Notice that insertion sort doesn't does fewer operations in this case than bubble sort. Bubble sort and how it works. Bubble sort is the simplest sorting algorithm that works by repeatedly sweeping that adjacent elements if they are in worrying order. How it works? Bubble sort compare adjacent elements if the first is greater than the second, sweep them. Do this for each buyer for adjacent elements, starting with the first two and ending with the last two. At this point, the last element should be the greatest. Repeat the step for all elements except the last one. Finally, keep repeating for one fewer elements each time until you have no more barriers to combine. Barriers to combine. As we can see, we have insertion sort versus bubble sort. The partitions of elements in the array. Inserting sort, the array is split into sorted and in understanding part. Bubble sort, sweeping the adjacent element. Worst case complexity. Inserting sort and bubble sort the same. Works well on insertion sort. Works remarkably well on data that is almost in order. Bubble sort, it's work well on smaller array. Additional storing space requirement. in insertion sort, in place sort, paper sort, in place, same, in place sort. Efficiency. Insertion sort is as fast as paper sort. Paper sort is slower than insertion sort. Typically, insertion sort stable and paper sort else stable. That's all for me. Thank you for listening. Salam alaikum.